Hello, today I am going to discuss about the PLC logic gates tutorial in PLC ladder logic programming. In order to save your time, I have created the PLC programming in advance so that it will not take up a lot of your precious time. Okay, today's discussion is about the logic gates. As we know, there are different type of logic gates. Okay, the first one is the AND gate, the second one is the OR gate, then followed by not AND gate or NAND gate, not OR gate, or sometimes people call it NOR gate, exclusive OR gate, exclusive not OR gate, or sometimes people call it exclusive NOR gate and NOT gate. Okay, so the AND gate, AND usually means two input arranged in series. OR gate, OR means two input arranged in parallel or branch. And the NOT AND gate, okay, the NOT is, for layman term, we can treat as opposite. So opposite to AND is usually is OR gate. So you can see the arrangement of the two input switches is quite similar to the OR gate. The only difference is both virtual switch are normally closed. Okay, similarly for the NOR gate, so not OR gate, not mean opposite. Opposite OR is AND gate. That's why you can see the arrangement is similar. The only difference is both using the normally closed virtual switch. Okay, as for this exclusive OR gate, this is the exclusive OR gate here. Okay, so it comes from the words OR gate. Okay, OR mean parallel. You can see two input switches arranged in parallel. Since it is exclusive, so you will have extra two switches here. Okay, this switches actually from here and these switches actually from here. It must be exclusive. That's why both are normally closed. Similarly for exclusive not OR gate. Okay, so it's almost similar to this exclusive OR gate. The only difference is the first round are normally open for both the virtual switches and the second round is normally closed. Okay, then the NOT gate, NOT mean opposite. So this switch 0, if is normally open, this one should be normally closed. NOT also can be treated like a close, so it is a normally closed virtual switch. Note that it is just a layman term. Okay, if we use too many technical term, it may be quite confusing. I prefer to use a layman term when explain something. All right, so how these logic gates works, maybe I can go through the theory very briefly so that it will be easier to explain. All right, so let's say this is a PLC. Okay, the central part of the PLC is a CPU. Okay, here is a digital input and here is a digital output. The whole thing is one PLC physical device. So inside the PLC have a very simple basic ladder logic programming. Okay, so this digital input terminal point 0, terminal point 1, terminal point 2, and of course have some other digital input terminal point. Similarly for the digital output terminal points here. So this digital input terminal point 0 is connected to external physical switch 0, which is a normally open switch. And similarly for the digital input 1, which is connected to the external physical switch 1, which is a normally open switch. As for the digital output terminal point 0, 1, 2, and so on, they are connected to the external load. In this case, is the lamp 0, lamp 1, lamp 2, etc. Okay, so what happened is if this switch 0, okay, is pushed to close, so it will be triggered physically from normally open to close. So the actual current, all right, the actual current can flow through the circuit. Okay, if let's say you push the switch to close, the actual current will flow through the circuit and then enter into the digital input terminal point 0 and energize is internal LED 0 and internal digital input load. So what will happen is because the internal LED 0 is energized, it will cause the relevant virtual switch to trigger. Okay, if the virtual switch initially is normally open, it will be triggered to close. If the virtual switch is normally closed, it will be triggered from normally closed to open. Okay, similarly for switch 1, if it is triggered to close physically, right, the actual current can flow through the circuit to enter the digital input terminal point 1 and energize the internal LED 1 and is internal digital input 1. Because the LED 1 is energized, it will trigger 11 virtual switch from normally closed to open or from normally open to close. Alright, let's say for this case, for this digital input 0 LEDs is energized, what happened is this virtual switch bit 0, which is linked to this input terminal 0. Okay, this normally open virtual switch will trigger from normally open to close. Thus, the actual, not sorry, the virtual. Remember the keyword virtual. I'm not talking about actual. Okay, this is virtual since the programming is exists in the memory only. This switch and this output coil are just virtual. It exists only in the program, not in the physical device. So the virtual power or virtual current will flow through the rung and energize the digital output, which is a virtual output coil. And because of this, it will cause the digital output 0, which is terminal point 0, internal LED being energized. Because the digital output LED, internal LED 0 is energized, it will cause its internal normally open switch to be triggered from normally open to close. Thus, the current can flow through the circuit and cause the light 0 or the lamp 0 to turn on. Okay, similarly, if switch 1 is pushed to close, the actual current can flow through the circuit to energize the digital input 1 internal LED 1. And because the LED 1 is energized, it will trigger its relevant, okay, relevant virtual switch. Okay, in this case, it's normally closed to open. Alright, so it will trigger it to open. Thus, virtual power cannot flow through the circuit, and this virtual output coil will remain de-energized. So nothing will happen for this bit 1, that means which is linked to input, the terminal point 1. Alright, okay. So as I mentioned, as for this one, okay, if the physical switch 0 do not push to close, so the state will be 0. If the switch is close to close is pushed to close, the state is 1. So 0 mean open, 1 mean close. Alright, once the switch is closed, the actual current can flow through. Okay, so now both switch 0, assume that both switch physical switch 0 and switch 1 are not pushed to close. That means they are remain open. So the external switch are both open. So it is in 0 state. Thus, both the virtual switch will not be triggered because the both external switch are open. So the normally open will remain open. The normally closed will remain closed. So what happened in this round is both is 0 state, right? So 0, 0, this one output is 0. So okay, as for the OR gate, okay, if this one, because all the virtual switch remain untriggered due to the reason that external physical switch do not push to close, so the normally open remain open, which is 0. Normally open for this one remain 0, which is open. So 0, 0, the output will be 0, meaning de-energized. The virtual output coil is de-energized. As for this not AND gate, okay, because it is normally closed, it remain closed for untriggered condition. And this one will remain normally closed, remain closed. So it's a 1. So 1, 1 here, the virtual power can flow through this round to energize the virtual output coil. That's why you see it is energized. As you can see the green color highlight here. Thus, it will cause the lamp to, okay, the physical lamp to, which is connected to digital output terminal point to light out. That means it will be activated. That means will be the light will be lighting out. Okay, and it's the same for this not OR gate. Okay, so normally close, remain closed, normally close, remain closed. 1, 1, this one be 1. And same for this one and this one. You can see 0, 1 is 0, 0, 1 is 0. So the output will be 0, the energized. 0, 0, 1, 1. So it will be 1 here. Okay, so to make it easier to understand, the series or the AND, you can treat as multiply. Or, which is branch, you can treat as addition. 0 times 0, 0. This one 0 plus 0, 0. This one 1 plus 1 is 1. That's why you see the lamp tube can be turned on. Note that I talking about the logical expression, not the mathematical calculations. That's why 1 plus 1 is 1 instead of 2. Because this is a logical expression. Okay? 1 times 1 is 1. That's why this one turn on. This one series, which is n, which is multiply. So 0 times 1, 0. As for this one, 0 times 1, 0. Then this one and this one is parallel, which is OR. OR mean plus. So 0 plus 0, here 0. As for this one, 0 times 0 is equal to 0. This one in series, so 1 times 1 is 1. So both parallel, so parallel mean OR mean plus. So 0 plus 1, the output is 1, is energized here. Okay, let's say I will simulate, okay, this switch 0 push to close. So what happens, actual current will flow through digital input terminal point 0 and energize this LED 0. This will cause a relevant virtual switch to trigger from normally closed to open or from the originally normally open to close. Alright, okay, now I trigger this to close. I will trigger this to simulate the external physical switch 0 being pushed to close. You can see what will happen. Okay, so 1 times 0 is 0, so output is not trigger. So 1 plus 0 is 1, the output is trigger. 0 plus 1, 1, output is trigger. Then 0 times 1 is 0, output is not energized. And then this 1 times 1, 1. 0 times 0, 0. So 1 plus 0, 1. You can see this virtual digital output coin is energized. Thus, the lamp for will light on. Okay. Similarly for this one. 1 times 0, 0. 1 times 0, 0. 0 plus 0, 0. Nothing happened. And then because this one 0, this one is trigger. As I mentioned, the switch 0 external physical switch is pushed to close. It will energize the internal LED 0, and then it will trigger all the relevant switch. So this switch 0 is triggered from normally close to open. So it is 0, so the output is 0. Okay, so let's say the external switch, alright, this external switch 0 is open. Okay, then external switch 1 is pushed to close. So the actual current will flow through the digital input terminal point 1 to energize its internal LED 1. And this will cause all the relevant virtual switch to trigger, whether to trigger from originally normally closed to open or originally normally open to close. Okay, so let me toggle bit this one and then toggle bit here. Then you can see, okay, 0, 1, 0, 0 plus 1, 1, and so on. So now I simulate, okay, both switch is triggered to close. That means both current will flow through the digital input 0 and digital input 1. So both LED 0 and LED 1 will be energized. And this will cause all the relevant virtual switch which is linked to digital input 0 and digital input 1 to trigger from normally open to close or from normally close to open. Alright. Okay, now I will toggle bit both switches to simulate the both switch 0, switch 1 physical switch to, to trigger from normally open to close. Okay, now you can see what will happen. 1 times 1 is 1. So the virtual output coil is energized and the lamp 0 will turn on. Similarly for this one, 1 plus 1 is 1. You can see the output lamp 1 will be turned on. And then this one, because as I mentioned, both external switch is switched on, meaning is pushed to close. So both the internet LED is energized. All the virtual switch will be triggered. So you can see this virtual switch originally is normally closed. That's why it's triggered to open. Same for this one. So 0 plus 0 is 0 and so on. Okay. So if you have any question, please leave a comment down here. Thanks. Bye.